Now we're going to turn to the labor market itself and what equilibrium looks like there. So, like any other market, the labor market reaches its equilibrium when the wage equates the quantity of labor demanded and the quantity of labor supplied, right? And we want to keep in mind that on our supply side again, it's going to be workers, the laborers representing that curve, and for labor demand, it is the firms. Okay. So the quantity of labor that firms demand is equated to the quantity of labor that workers are willing to supply in equilibrium at that given market wage, right? And that's how we see how much labor is ultimately hired in the market. In our market, we're not just considering a single firm and how much labor they hire, but all the firms. And again, it's what all of the firms together are hiring at that going wage. Okay. Now that we've discussed how the firm's demand for labor, the individual firm's demand for labor changes in the short run, we saw shocks to the marginal productivity of the worker, the marginal revenue of the firm, and wage changes. We want to now consider the long run, right? How does that labor market change between the long run and short run? And just like we started this course off with, it has to do with capital, right? In the short run, we assume that capital is fixed, but in the long run, right, the firm can change the amount of capital it uses, and labor and capital are often substitutes for each other, right? So when the firm can vary how much capital it hires, that's going to impact directly how much labor they hire as well. They're substitutes, but then, right, in some production functions, they're also complements, right? Um, so as capital is substituted for labor, we'll see the amount of labor dropped, but as capital complements labor with more capital, we'll see more labor hired. All right, so it's going to depend fundamentally on the firm's production function. When you have a Cobb-Douglas production function, right, where capital and labor are multiplied together, that means that they're complements, right, primarily. They substitute for each other somewhat, but primarily they're complements. However, when you have a production function that is additive, for example, this is when you're going to see capital and labor be substitutes, okay? The way that we know is by looking at the marginal productivities of these inputs. So for labor, we're going to see that as the amount of capital goes up, when we have a Cobb-Douglas production function, labor becomes more productive. In our alternative production function here, if we find the marginal productivity of labor, we see that it only depends on labor itself, right? Capital goes away because it's treated as a constant, all right? And it's just the amount of labor that impacts how productive it is, all right? So because we're going to assume that most firms are working with a Cobb-Douglas production function, we're going to be talking about capital and labor primarily as complements to each other, okay? Um, The reason we make this assumption is that it tends to be true, right? When we look at the production data for real life firms, it tends to be that we have, at least to some important degree, labor needing capital to produce and capital needing labor to produce. It's very rare that we have just workers producing a thing or just capital producing whatever the good is. Okay. So we're going to note primarily that, as I've pointed out here for us on the slide, as the amount of, oops, sorry about that. As the amount of capital hired changes, it's going to affect labor's marginal productive labor and thus shift the firm's labor demand curve. So let's look at some examples. First, let's do an increase in capital, right? Let's say that capital goes up. And we can draw our graph here. So we have the marginal revenue product of labor and the constant wage, and their intersection gives us the amount of labor hired in equilibrium. If the firm hires more labor, right, and excuse me, if it hires more capital, and we're assuming that the marginal product of capital looks something like this, right? More capital means that labor is more productive, and so that marginal revenue product curve is going to shift out, and more labor is hired. Okay. If instead capital decreases, oh, sorry about that. Oh, how do we stop? There we go. Okay. If instead capital decreases, we're going to expect marginal product labor to decrease. And so the marginal revenue product for that firm is also going to decrease. And so they're going to hire fewer workers at the going wage. Okay. So this is how changes in capital are going to affect our firm's demand for labor. It's through that marginal productivity variable. All right. So let's look at another example. So we'll do first short run effects and then long run effects. So let's say for some reason that the wage for workers drops, that equilibrium wage falls. Initially, we're on this blue marginal revenue product curve for the firm. And so their amount of labor hired is going to increase in response to the decrease in price from L1 to L2, right? Initially, they were at point A, now they're at point B. Because they're hiring more workers, right, that's going to mean for their capital, it's going to become more productive. So if we show our marginal product of capital here, right, as the amount of labor hired goes up, marginal productivity of capital goes up. All right, and so the firm's going to hire more capital. What that means then for labor is that labor in the long run, right, because that capital adjustment happens in the long run, as more capital is added, labor is becoming more productive as well, right? So as capital goes up, marginal productivity of labor goes up. So as we shift into the long run, that increase in capital, because capital has become more productive, so firms hire more, shifts the marginal revenue product of labor for the firm's demand for labor out into the right. And at the new lower price level, now they increase their amount of labor hired even more. Right now it goes to this L sub 3. And the firm is at equilibrium C, right? And so what we can do is actually connect equilibrium A and equilibrium C to find the firm's demand for labor in the long run, right? And you can see that it is more flat, it has a flatter slope than the short run marginal revenue product curves that we drew for each stage of the adjustment. And that's just reflecting that um, underlying driver of price elasticity of demand, where as you switch your consumption timeline from the short run to the long run, you become more responsive to price. So in the short run, the firm, in response to the price drop, increases their quantity of labor hired a good bit, but in the long run now they're increasing it even more. All right, so that's what we're seeing there. And then this is explaining here why we see a change in the amount of capital used. Again, it's because more labor used in the short run increases the marginal product of capital, like we just discussed. And when that firm hires more capital in response, then labor also becomes more productive, shifting the marginal revenue product of labor and getting us to this equilibrium C, and even more labor being hired in the long run in response to that lower wage. All right, and that's a conclusion you can see summarized here. Okay, let's say that uh, oh, we're still summarizing here on these slides. I apologize. I was going to move on. But this just summarizes, right? If we have a decrease in wages, the firm's use of labor will be greater in the long run than the short run, which is again reflecting that flatter long run firm demand for labor in the long run than in the short run. Okay, and why might that be, right? Firms might hire temporary workers in the short run, believing the wage might go up again. But if they think the wage is going to persist, they're going to continue to bring on more full-term employees. Now we're going to look at an increase in wages. So we're going to go the other direction. So let's start at point C, right? At point C here. If the wage goes from wage 2 to wage 1, that's going to put us at this new equilibrium point, all labeled D. And we're going to see a reduction in the amount of capital hired from L sub 3 to L sub 4, right? Price goes up, quantity demanded falls. And so initially in response to this wage change, folks lose their job. Maybe there are layoffs, maybe there are furloughs, however the firm decides to deal with it. But because now there are fewer people being employed by this firm, it means that their capital goods are going to be less productive, right? Um, Let me just write this up here for us. So as labor falls, capital's productivity falls. And because capital's productivity falls, we're going to expect that the firms are going to reduce the amount of capital that they employ. And so when the amount of capital employed decreases, we're going to see the firm's labor become less productive as well, shifting the marginal revenue product of labor back into the left, right? Down into the left, placing us at point A. So we see then in the long run with that capital adjustment, more folks are fired in that long run, right? The firm is using less and less labor. Okay. All right. So again, other perfectly competitive factor markets here. We focused in this course most on capital, right? We simplified our model such that labor and capital were the only inputs we considered, but any input that the firm uses in production is going to be subject to the same type of analysis that we've subjected labor to, right? If we focus on capital, we can draw the firm's demand for capital. It's also going to be that marginal revenue product, but it's going to be for capital instead. And it's going to be showing us the relationship between the amount of capital hired and the rent, right? That's the price for capital. And we can find that marginal revenue product of capital by multiplying the marginal product of capital by the firm's marginal revenue, right? Same relationships here. And if we were in a perfectly competitive market, that price for capital is going to be constant, just like the price for labor is. And the intersection between our two curves gives us the optimal amount of capital hired. Okay. All right. Um, Besides capital, we're going to have other inputs that you could look at. So intermediate materials like leather to make shoes or gloves, lumber to make tables or chairs, or steel to make cars. Potentially business services, right? If someone offers a consulting service or a printing service or design service, right? Those are all going to be inputs. Energy, right? You need electricity for most things nowadays, and even land, right? Okay. And again, right, we're going to see that the marginal revenue product for any factor is going to depend on the marginal product of that factor. So you could say marginal revenue product of that factor equals marginal revenue, the marginal product times marginal revenue. And each of these marginal revenue products is going to exhibit that downward sloping behavior, right? Because that marginal product for any given good is going to decrease as the amount of that good used increases. Okay. And so we're going to see that all of these marginal revenue products, regardless of the input considered, is going to behave like a demand curve. Okay. The optimal amount hired of any given factor is going to be where the price of that factor equals the cost to the firm to hire it, right? So where those benefits equal cost, that gives us the optimal amount used. And then to see the total amount used in a given market, we're going to sum up how many, say, pieces of land, acres of land that each firm in that market employs. Okay. All right. If we consider the supply for any of those factors, it's going to come from the owners. So if I am producing coffee machines, right? I'm supplying them to the coffee shop. If I'm offering design services, right? I am the supplier of those services. So these markets, even though they seem more complicated, they follow the same rules as the markets we've covered in this class. Okay. One that might cause some difficulty is land, right? In general, it's very difficult to increase the amount of land available. So usually it's graphed as having a perfectly inelastic supply curve. And so it doesn't matter how much demand there is for this good. All that's going to happen is the price is going to change. The amount of land is often not going to adjust. This is not always true. Like we've seen China, for example, be very successful in creating additional land, adding sand to the coast, or some countries use coral reefs to increase the amount of land. But what we can think about is that the use of the land is variable. So consider Camp Pendleton, right? If the price for that land got high enough, we might, see some of it sold to developers, to build housing, to farmers for agricultural use, whatever, depending on how valuable land for residences is compared to land for military use, right? Okay. All right. And with that, we're going to stop our discussion here, and then we'll turn to practice problems.